The next question, number 3. So number 3, this is figure 4, show the long straight wire, right? So now this is carrying 4 ampere is placed to the left of circular loop. The loop has diameter 0.04. The current flow in the loop here is 2.0 ampere. So calculate the magnitude and direction of the net magnetic field at the center of the loop. So if you look at the loop here, this is at the center of the loop. So what is the total magnetic? So it's total of magnetic field here. Because of first magnetic field is come from the conductor straight wire I1 4.0 ampere. If you use the right hand, so right hand, right, it's the right hand here, the direction of the current or thumb is to downward. So the magnetic field direction produced by the I1 here is out of phase, right? Out of phase. So at the point B here, this is direction of the B. So if you use a diagram, this is out of phase. This is B produced by the I1 or B1. Now the second B is come from the wire or loop wire by current flow in the loop is 2 ampere. So if you use the right hand, the direction of the, this is direction, let's say this is the thumb, and this is direction of finger, okay? The finger direction is into the page. So meaning the B produced by the, let's say, loop current or B2 or I2 here is into the page. Sorry, this is the symbol is a X here. So now you have a, so if I draw the at the center here, you have the first B1 produced, sorry, the first B1 produced by the conductor straight wire or B1. The direction is out of phase, and the second B is come from the loop wire or I2, right here B2, the direction into the page. So now combination B1 and B2 here, to calculate the B for the straight conductor wire, B equation is equal to, right, B1 here, the equation for straight wire, nu naught, constant current flow I1 divided by 2 pi r. R a distance from straight wire to the center here. So this is center, okay, the R here, right? B1 nu naught I, this is I1, current flow is 4 ampere, and 2 pi r, R a distance from wire here to the center, this is R. The value of the nu naught is constant, this is 4 pi exponent minus 7, and the current flow I1 is given 4 ampere, 2 pi constant, and the R distance 0.004, so the B1 is equal to 4 exponent minus 3 Tesla. So direction of the B1 is out phase, right? And the second B or B2 is produced by the loop here or I2. So we refer to the B2 here. For the loop at the center, B equation, to calculate the B at the center for the loop system, the equation is a nu naught I, the current flow in the loop is I2 divided by 2R. Now the value of the nu naught is constant, the same for pi exponent minus 7, and the I2 now we have 2 ampere and 2, and this is r here, the distance here, the radius here is 0, 0, 4. 0 point, sorry, the distance here 0, 0, 4, meaning the half is 0 0.02. 0 0.02. So now the B2 is 6.3 exponent minus, this calculator is, I think this is a minus 5, right? No, this is not minus 3, this is minus 5, right? So because of direction of B1 and B2 is opposite direction, you can use another B1, or you can use a B2 is negative or positive. Let's say the B1 is a positive, 4 exponent minus 5, plus, and the B2 is negative 6.5 exponent minus 5. So meaning the resultant magnetic field B at the center of the loop is equal to negative 2.3 exponent minus 5 Tesla. So the negative here because of direction of the B into the page, meaning because of the magnitude of the B2 or into the page is greater than B1 out of page. Next question, figure 5 show the proton speed 2.2 exponent 6 meter per second enter the region uniform B. So you have a magnetic field B here, and the plate is separated, so the distance here is 0.18 meter. Number 1, this means the direction of magnetic force on the proton and sketch its trajectory when it enters the region between the plate. As you know, when the charge or when the particle or proton enter to the magnetic field region here, so we have combination B, magnetic field, speed of the particle, and we have force X on the particle or the proton here. So if you use the left hand, so direction of your thumb is direction of the force, and the first finger is the direction of the magnetic field B, and the third finger is this is direction of V, speed of the proton. So if you use the left hand here, direction of the B is into the page, and direction of the V, direction of the V is now direction of the V here is, this is V, this is B, and the force is here, okay, because F B 90, this is 90, so left hand, use a left hand, the direction of the force into the upwards. So if you draw the circular part here, meaning when the particle enter the magnetic field region B, so the first is direction of the proton is straight to the right, but because we have the force X on the particle, the direction of the particle is here, and still to moving to the V here, but now also have another force here, and here we have a force here. So meaning if you draw the this is the first enter and the next enter to the region, so the direction of the particle is a semicircle, because the force here is always direct to the center, or this is centripetal force Fc is equal to, this is semester 1, centripetal force mv squared divided by r. R is a radius, this is r. So if the known magnetic field B, the direction of the proton is strict to the right, because of when the magnetic field B at the region B here, so the force acts on the particle that produce force here is a magnetic force Fb, and because this is a semicircle, or refer to the centripetal force, or Fb is equal to Fc, right? Number 1 is. Number 2, what is the maximum magnitude of magnetic field so that the proton does not hit the opposite plate? So meaning the first is when they enter the region, so this is a direction, right? So to find the maximum magnitude of magnetic field so that the proton does not hit opposite plate, meaning the force Fc is equal to mv squared divided by r here. The radius here is equal to the radius of 0.18. The r here is 0.18, so the proton does not hit the opposite plate. But Fc is equal to Fb. Fb is a magnetic force. The magnetic force is a equation Q V P sine theta, right? The sine theta, theta here is equal to 90 degree, because the angle between B into the page, right, into the page, and direction of the V to the right, meaning the theta is 90, so this is equal to 1, and the magnitude of the B here is given by the question is equal to, no, this is the B is question asks you to calculate B. The V here, because this is same value V, you can cancel here, and the charged proton, so charged proton is constant, is 1.6 exponent minus 19 coulomb, and the mass of the proton is constant value. The mass of the proton is 1.67 exponent minus 29, right? So now you can find the value of the B here. So the final answer, if you use the calculator, the B here 0.128 Tesla, so that the proton does not hit the opposite plate in the system. So that's all. Thank you.